Good morning, everyone, and welcome to MJ Magic Studio. That's MJ's Maths and Stats. And today we'll take up multivariate analysis techniques. Actually, let's start by taking few situations. Uh, Maybe like an executive walks into your office with a stacks of printouts, and he says, "The marketing research analyst, tell me how many of this new red gadgets which we have produced we are going to sell next year. We don't know what price we can get from it either." And maybe take up one more situation where another executive walks in your office and asks you to come to his office, and he shows you three different proposed advertisement campaigns for next year. And then he asks, which one should I use? They all look pretty good to me. Different advertisement campaigns. Whether that particular gadget will sell or not, and they don't even know the prices. During the annual budget meeting, the sales manager actually wants to know why two of his main competitors are gaining shares. Do they have better gadgets than us? Do their products appeal to different types of customers? Actually, what is going in the market? Hello, I'm Mohit Jain, and let's see about these three different situations which we picked up right now. All of these situations are real, and they happen every day across any corporate, whether it's in India, America, Africa, or Australia. Fortunately, all of these questions are ones to which solid, quantifiable answers can be provided. Full stop and a question mark, both at same point of time. A marketing researcher quickly develops a plan of action to address this situation. As a researcher, one should realize that each question requires a specific type of analysis. We can't run same type of analysis to find answer to these. Whether I would be able to make sales or not, what should be the price of my product, which advertisement campaign will work, why I'm losing out on shares, what is actually going in the market. Each question requires a specific type of analysis. And researcher may reach into the analysis tool bag, and today we will discuss what different kind of analysis we have in this tool bag. Over the past 20-25 years, the dramatic increase in desktop computing power has resulted in a corresponding increase in the availability of computation intensive statistical softwares. Programs like SAS, programs like SPSS, once they were actually restricted to mainframe utilization, but these programs are now readily available in Windows-based packages. The marketing research analyst now has access to a much broader array of sophisticated techniques with which he can explore the data. The challenge becomes knowing which technique to select, because we have many, and clearly understanding their strengths and weaknesses. My father once said to me, if you only have a hammer, then every problem starts to look like a nail. आपके पास अगर सिर्फ एक हथौड़ा है तो हर एक प्रॉब्लम आपको नेल की तरह ही दिखेगी और दिखना भी चाहिए. This is the purpose of today's lecture. So, in the nutshell, the purpose of this particular lecture is to provide an executive understanding of different multivariate analysis techniques. Maybe like I would be listing 11 different multivariate analysis techniques, resulting in an understanding of the appropriate uses for each of the techniques. This is actually not a discussion regarding the statistics which is involved with each technique. Maybe like this lecture can be used as a guide to understanding the types of research questions that can be formulated and the capabilities and the limitations of each technique in answering those questions. A researcher always starts with a research problem. And these techniques help in formulating our research questions, which we actually need to answer by the end the research is complete. In order to understand multivariate analysis, it is important to understand some of the terminology or nomenclature which I might be using during this lecture. What do we mean by a variate? A variate is a weighted combination of variables. A variate is a weighted combination of variables. And you know where lies the actual problem? The purpose of the analysis is to find the best combination of weights. Then we have non-metric data. Non-metric data refers to data that are either qualitative or categorical in nature. Non-metric relates to qualitative data. And similarly, metric data relates to data that are quantitative and interval or ratio in nature. They will give us numbers. So the three basic terminology we should understand is non-metric data means qualitative data, metric data means data which can be quantified, and variate is nothing but a mixed combination of different variables which we have in our study and the weighted combination of that. And our job is to find that exact weights in which variables to be used to define our variate. Before actually starting up with an analysis technique, it is very important to have a clear understanding of the form and quality of the data. You need to understand in which form it is and what is the quality of the data. The form of the data refers to whether the data is metric or non-metric. Accordingly, we will be choosing our analysis technique. The quality of the data refers to how normally distributed the data are. जितना ज़्यादा the data would be close to a normal distribution, उतनी ज़्यादा हमें help मिलेगी in formulating our hypothesis, in testing our hypothesis. Because majority of the time, most of these tests of hypothesis are based on the assumption that our distribution is normally distributed. The first few techniques which we will be discussing are sensitive regarding the normality of the data and equal variance assumptions of the data. That's why we are focusing more on normally distribution of the data. Examination of distribution, skewness, kurtosis may be helpful in examining distribution. With help of that, we can find whether this particular distribution is more inclined to a normal distribution or not. Also, it is important to understand the magnitude of missing values in observations. And it is also important to determine whether to ignore them or impute values of the missing observation. Missing observation hai, we need to identify whether ignorance is fine here or we need to impute the values of these missing values so that we can move ahead with the data. Another very important quality of data or another data quality measure is outliers, जो इस एक्चुअली डेटा स्ट्रक्चर्स को खराब करते हैं. गेहूं के साथ घुन, दाल में कुछ पत्थर, गेहूं को साफ क्यों करना पड़ता है जब घर लाया जाता है तो चावल बिनना, जो इम्प्योरिटीज आप बाहर निकाल देते हैं, those are known as outliers. It is important to determine whether the outliers should be removed or not. Maybe like important to recognize whether you need to remove negativities from our life or not, और उनके साथ भी चल सकते हैं. If they are kept, they may cause a distortion of the data. And if they are eliminated, they may help with the assumptions of normality. It is always recommended to identify the outliers ASAP and try to neutralize them. The important key is to attempt to understand what the outliers represent, whether they are important for that particular set. Obviously, they are not. Many a times we try to identify them and try to eliminate before proceeding with analysis techniques. So as said, I won't be describing different multivariate analysis techniques and the statistics attached to it in detail in this particular lecture, but we will take up each technique one by one and we will try to analyze it in detail in some other lectures. Next, we can take up the famous factor analysis. An entire video on this is available on the channel very soon. When there are many variables in a research design, it is often helpful to reduce the variables to a smaller set of factors. बहुत सारे फैक्टर्स हैं हमारे पास जो कि उस पर्टिकुलर इवेंट को, उस पर्टिकुलर क्वांटिटी को, उस पर्टिकुलर वेरिएबल को इन्फ्लुएंस कर सकते हैं. Now, out of those many variables, we need to find the important set of variables which are affecting that particular outcome. So for that, we run a factor analysis. Next, cluster analysis. actual purpose of cluster analysis is to reduce the large data set to meaningful subgroups of individuals or objects. छोटे छोटे ग्रुप्स में उनको डिवाइड करना. So to conclude this particular introduction on multivariate analysis techniques and 11 different multivariate analysis techniques, I can say that each of the multivariate techniques which we have described here has a specific type of research question for which it is best suited. Each technique also has certain strengths and weaknesses that should be clearly understood by us as a research analyst before attempting to interpret the results of the techniques. There are many statistical packages like SAS, SPSS, S+, which is making it increasingly easy to run a procedure, but the results can be misinterpreted if adequate care is not taken while handling the data. I'll come back again with detailed lectures on these 11 multivariate analysis techniques one by one. Till that time, stay connected. This is Mohit Jain signing off from MJ's Magic Studio, or as we call ourselves now, MJ's Maths and Stats. See you, and believe me, magic happens.